everyone. My name is Dr. Valerie Meyer-Spiridolosi, and I teach Industrial and Systems Engineering here at the University of Rhode Island. The Yukon URI Navy STEM Coalition works with the National Institute for Undersea Vehicle Technology and our partners throughout the region who build submarines and support the U.S. defense industries. Come take a look what we're doing.
Hello everyone, I'm Birendra. I hope you are doing well. I am part of the Dynamics Photomechanics lab at the University of Rhode Island College of Engineering. Today I'm going to show you one of the cool stuff that we do in our lab. On my hand, you can see this textile fabric with some neat features in it. If you look closely at some of this lining in here, what do you see? Oh, those are good observations. As you can see here, we have a textile fabric and you have these stitched fibers, and these stitched fibers are made of copper. Why do you think we use the copper thread in this composite material? Why copper? Copper, if you remember, it's a metal. And metals are very conductive in nature. Using the conductive nature of copper, we leverage the data transfer ability of these composite materials. As engineers, we have to consider different applications these fabrics can be used. One of these potential applications could be wearing it. You can use this for military applications. Military vests that you see, they are laced with these copper fibers in there, and from there you can use it to measure the body temperature, to heat it, measure the heart rate, so on and so forth. What design problems we may encounter while making a structure out of this? To be able to test that, we use this nice machine that you can see, which essentially extends this fabric to its limit, and from there you know how this fabric stretches and also how this copper stretches. You have this top and bottom jaws which clamps your specimen, and we move this upper jaw so that we can test this malleability of your structure. In this case, the fabric itself. At certain point, once you stretch it enough, the fabric itself will break. We would want to avoid that, because at that point everything fails, right? We get all the data before the failure actually happens. Let's try it out with the actual specimen. Let me ask you a question before we start the actual experiment. What do you think will break first, the fabric or the copper? So to explore the multifunctionality nature of these copper conductors, we have these leading wires, as you can see, that goes into this data transmission box, and this filters out the signals, and we use the software from the computer to get the readings or the voltage output. So what do you think might happen to the electrical signals when you stretch the copper? In our case, since we are stretching these copper conductors, we are including some resistance to it, and the resistance is converted to the electric signals, which you can use for data transfer capabilities. So what do you think you can use this fabric for? Think in terms of how you can use it personally or even in your society level. This can be used for all sort of applications, your temperature control, heart rate monitoring, so on and so forth. As you can see, we work with real world problems and provide real world solutions to that, and we play with materials. You might want to consider joining us as mechanical engineers. Maybe I will see you on campus sometime. Bye.